7.5 special types of linear systems. All right, we're going to take what we, actually this should be kind of a review in a way, because you've been introduced to graphing lines and telling me if they have one solution, no solution, or infinitely many solutions. Who can give me an example of what a graph would look like if you had one solution? If I had a graph that had one solution, here's my graph, and then I put two linear equations on there. What would happen to those two linear equations if we had one solution? What would they do? Cross. So say I graphed that linear equation, I graphed this linear equation, they cross. Right here where they intersect is their solution. It has one solution, and that's where they cross. Now here, they've taken these two lines right here and graphed them. Are yours graphed on your notes? No. Okay. Well, rearrange them. And when these end up getting graphed, we'll graph them here in a minute, they're parallel. How many solutions do parallel lines have? This system would have how many solutions? Do they cross? Never. So there's not one because they don't cross. They never cross. They never touch. So how many solutions? Zero, or none, or no solutions if they're parallel. And if we don't have a graph to look at, if you solve the linear system, you'll know they're parallel if you get 0 equals 5 or negative 1 equals 2. That is not balanced, is it, the equation? The x and the y have all canceled out, but these two numbers are not the same. So that tells you there are no solution. No solutions, so those lines are parallel. Over here, when we talked about when we had them when they crossed, and we have one solution. Well, if we solve that linear system up here like this, it would end up being an x equals like 3, and your y would equal 2. When you solved it, you'd have your x and your y do not cancel out. You'd have one x left or one y left. That's one solution. That's what it would look like. What would your graph look like if you had many or infinitely many solutions? What is that graph going to look like? I'll tell you what it'll look like if you'd solve it using combination or substitution. It would be 0 equals 0 or 2 equals 2. Those are just two examples when both numbers on each side of the equal sign are the same. That's infinite many. Infinite all solutions. But what would the graph look like for infinite? If all solutions work for that system. You may want to guess? Say that's the line. What would the other line be then in the system if it's all numbers or all ordered pairs or solutions?
0, 0.
What's the other line going to be? Perpendicular? No, good guess though. That would be just one solution. That would be where they cross. What would it be? It's the exact same line. You have the two equations are exactly the same in the system. All right? And if you didn't see it on a graph, when you worked it out with combinations or substitution, your numbers are going to be the same on both sides, and your x and your y have already canceled out. All right? So that's what we're going to practice. With that knowledge, I have to move this. I guess I already put mine on. First thing we need to do what? We have to figure out graphically what this is. So to graph it, what do I need to do to this? Excellent. Rearrange it into slope-intercept form. So I need to plus an x to both sides. Now I have y equals x minus 3. All right? Write that down and show that you've rearranged it. Now graph it. Is that my top line or my bottom line on my graph? Bottom, because my y-intercept is the -3, and my slope is a x or 1x. That's the same as 1 over 1. So right one, up one, right one, up one, and so on. Or left, down, or down. Questions on graphing that one? All right, now we need to rearrange this one. What do I have to do first to rearrange this into slope-intercept form? Good. Add x to both sides. So I have y equals x plus 2. So y equals x plus 2. That's a 1. Is that the same exact line? No, this one goes at the -3 and this one goes through the y-intercept at the 2. But what do we notice about these two? They have the exact same what? Slope. So we know since their slope is the same, they're going to be parallel. So we graph that at the +2. Right one, up one, right one. They are now parallel. So what would I label that? 1, none, or infinite? Louder. Good. This would have none. That has no solutions. That's what it looks like on a graph. Now let's take those same two equations and solve it using combinations. Do I need to rearrange or are they already neatly lined up? Do I need to? No, they're already neatly lined up. Do any of them eliminate? So what do I need to do? Multiply by a -1. Does it matter which one? Okay, let's just multiply the top one then. That turns this into a +x minus y equals, and the negative times the -1 is a +3. All right? Now what cancels out? My +1x and my -1x, those cancel out.
And your y's.
Ooh, my -y plus y, those cancel out. So what's left over here? 0 equals 5. When we were talking about that, when the numbers aren't the same on both sides, how many solutions do we have? None. There are no solutions because these lines are what?
Parallel.
They would be parallel. How about if we use the substitution method? Here we have y equals x minus 3. So in for the y, put your x minus 3. So I have a -1x, I'm bringing that straight down, plus x minus 3, that still equals 2. All right, solve, get rid of parentheses, we'll bring my -1x down. What's a positive times a positive?
Positive.
I have a +1x still here. What's a positive times a negative?
Positive. Negative.
-3 equals 2. Now what can I do? Combine my like terms, excellent, and they do what? What happens? They cancel out. Now I have a -3 equals a -2. My variables all canceled out. Are my numbers the same on both sides? No. Even if I were to +3 and move it over here, I get 0 equals 5, still not the same. So no solutions, none. Those lines would end up being parallel. All right, I want to come back to the graph. Let's do that one first out of the, or last out of these two. Okay, these are the same equations. Let's do the linear one first. What should I do? I need to multiply anything? Which one? Top one by? Okay, let's multiply the top one by 2. So 2 times 3x is 6x. I'm going to move it all down here. 2 times a +1y is +2y equals 2 times a -1 is -2. All right, now what? That's now gone. We now have a new one. Does anything cancel out here? What cancels out? A negative 6x and a positive 6x. Those cancel out. Negative 2y, positive 2y, gone. So 0 equals, what's 2 minus 2?
0.
Ooh, interesting. All my x's and y's canceled out. My numbers, I'm balanced. 0 equals 0, the same number on each side. What does that tell us? How many solutions? Infinite many. Yes, infinitely many. That's infinity and beyond. Because these are what? They're the same line. Are they really? What would happen? Let's see down here if we were to use the substitution method. What am I going to put in for y? What am I going to put in here for y, class?
Negative 3x plus y.
Right, and don't forget your parentheses in case you have to do the distributive property like we do here. So, negative 6x, I just brought that down, minus 2, brought that down, times y, which is now negative 3x, negative 3x minus 1, and then that equals 2 still. Do the distributive property. I'll bring my negative 6x down. What's negative 2 times negative 3x? What is it?
6.
Plus or minus?
Plus.
Plus 6x. And what's negative 2 times negative 1?
Plus 2.
Plus 2 equals 2. Now what do I have left? My negative 6x and my positive 6x. They cancel. Now I'm down to 2 equals 2. Do I really even need to go any further? If I did, I could minus 2, and I'd end up with 0 equals 0 again. But they're same, so we know that they're the same line. Again, infinite possibilities, infinite answers. Now let's go back to the graph. Before I can graph these, what would I have had to do to them? These are the same ones. Rearrange. What does this one turn into when I rearrange it for the graph? Y equals, got a minus 3x to both sides. So what does it equal? Negative 3x. What did you say? Minus 1? Correct. All right, now let's rearrange this one. Excuse me. I have to plus 6x to both sides. And that gives me what left? A negative 2y equals 6x plus 2. Am I done? No. What do I need to do yet? Yep, divide everything by negative 2. Now it's in slope-intercept form. Y now equals what? Negative 3x. What do I get here? Minus 1. There. See anything familiar? What ends up being? They are the same line. So they're going to be here. Start at the negative 1. And my slope is which way? Negative 3 over 1. Do the run first.
Slope.
1 down 3.
Right 1, down 3. How about if I go backwards? Yep, left 1 up 3. Okay, they're both, oops, missed 1. They're both the same, so it would be infinite. Right, homework worksheets, page 24 and 25.